All right. Hi, everyone. Welcome to my channel, Maths Made Easy with Terry in 10 minutes. Based on the previous video, I felt like we need to do a little more reminder on solve some more examples, okay, just to remind ourselves, okay? So I'm going to do 2 more videos because some of you talked about not just need a quick refresher on each of them. So I'm going to talk about things about sine, cosine in this video. Then I'm going to talk about a little bit of complex trig just in the next video, just few examples to remind ourselves, okay? So we're going to do a quick video on this so that we can just still be on the same plane. But like I said, I'm going to advise, please make sure you go to the previous video where I talked about trigonometry and try as much as possible to have a look at it, okay? So let's see this example here. So even if we're given a equation that theta is equal to 3/5, and we're now told to find, let's say, find sine theta and tan theta. Okay, we'll have sine theta, cos theta to be 3/5, and we're told to find sine theta and tan theta. So remember, I told you that I used the SOH-CAH-TOA. Okay. So for a right angle triangle, so let's get a right angle triangle up here. Okay. So this is if this is the angle we're looking at theta, this is the opposite. All right. This is the hypotenuse. And therefore this is going to be the adjacent. Okay. And for cos theta is what? Adjacent over hypotenuse. So I mean adjacent is what? 3. And the hypotenuse is what? 5. Is that making sense? So now we can get the opposite now using the Pythagoras theorem, where I told you that c squared is equal to a squared plus b squared. Okay, so that means the hypotenuse squared is equal to the adjacent squared plus the opposite what? Squared. You remember this? So now we can now use it together. So we can now say the opposite squared will be equal to the hypotenuse squared minus the adjacent what? Squared. Okay. And we can now get this. The hypotenuse is going to be 5 squared minus 3 squared. And this is going to give us 16. So that means the opposite now is going to be equal to square. Opposite squared is equal to 16. So that means the opposite is going to be equal to square root of what? 16. And that will give you 4. So that means the opposite here is equal to what? 4. So with that now, we can now get the rest of the question. So now we can now get sine theta. Sine theta is equal to opposite over hypotenuse. Okay, so the opposite is going to be 4. The hypotenuse is going to be 5. Can you see? Then we can also get the tan theta. Tan theta is opposite over adjacent. So the opposite is going to be 4 divided by the adjacent. That is going to give us what? 3. And that will be that for that. I'm going to pick one more for this. Okay, let me just pick one more for this so that we can summarize this one with that. So let's assume we have a question that said if sine theta is equal to 10/12, and we're told now to find cos theta and tan theta. Okay, we're told to find cos theta and tan theta. All right. So similarly, you can pause the video here and you can try as much as possible to solve it, and you can come back and check it. All right. So same thing is going to be we have SOH-CAH-TOA. Okay. So if you have a right angle triangle, so this is the theta, okay, and that is a right angle. This is going to be the hypotenuse. This is the what? The opposite, and this is the what? The adjacent. So sine is opposite over hypotenuse. So that means the opposite is going to be, this is the opposite over what? The hypotenuse. So the opposite is going to be equal to 10, and hypotenuse is equal to what? 12. All right. So now Similarly, we use the Pythagoras theorem. C squared is equal to A squared plus B squared. So that means C squared means the hypotenuse squared is equal to the adjacent squared plus the opposite what? Squared. Now we're looking for the adjacent, so we take the opposite square to the other side. So that means the adjacent squared will be equal to the hypotenuse squared minus the opposite what? Squared. And that will give you the hypotenuse is 12 squared minus the opposite is 10 squared. Then the adjacent, you can just do the adjacent squared. So the adjacent is going to be equal to the square root of 12 squared minus 10 squared. And when you put this in your calculator, your answer should be 2 root what? 11. So that means I can easily say that the adjacent is equal to 2 root 11. So with that now, I can get the remaining part. The first one, I can get cos theta. But we know cos is adjacent over hypotenuse. So it's going to give us adjacent 2 root 11 over what? The hypotenuse 12. And this is same thing as saying 2 here 1, 2 here 6. It's going to give us root 11 over what? 6. So that'll be answer for the first one. Now for the second one, okay, the reason why I wanted to solve the second one is just to remind us of the concept of sorts and conjugation of sorts as well. So for instance, tan theta is going to be equal to opposite over adjacent, so opposite. So tan theta is going to be opposite. What is the opposite? 10 over adjacent, and that's 2 root what? 11. So remember, I explained to you earlier, you can't leave your answers with sorts, okay, at the denominator. So to get rid of it, you multiply both sides by what? Root 11, right? Rationalizing the denominator. And that will give you 10 root 11 divided by what? 22. And when you simplify that, it's going to be 5 root 11 over what? 11. And that will be the answer for that. All right. All right. Okay. So I'm going to just solve one more example, but it's going to be in the next video. I'm going to just solve an example that have things like maybe we have something like sine 2 theta plus 5 is equal to maybe 8 cos 6x or cos 2x or cos 2x plus 5, something like that. Or I can solve something like 2 tan theta plus 8 is equal to something. So we're going to just play around with something, questions that have something like this. I have solved questions like this earlier, so you can go back and have a look at it, all right? All right, so I'm going to see you in the next video. If you have any question about this, SOH-CAH-TOA, how to use SOH-CAH-TOA to derive other angles, just put your question in the chat box, or you can send me an email and I'll get back to you, all right? Thank you very much, and I'll see you soon.